Okay, great. So I'd like to talk about what the Arctic Tern Group has been doing for the past few days. First of all, as we said before, the Arctic terns do this amazing annual migration from the Arctic down to the Antarctic and back again. So using geolocator and GPS data, we firstly identified these three main migration pathways that the Arctic terns use in their southward migration. And we then looked at the correspondence between their migration pathways and the winds they experience during that migration. And the terns definitely exploit the surface winds during the migration to facilitate their northward and southward migration. We also looked at how these winds might change from now into the future using the UKESM predictions. And this diaphragm plot on the left shows the changes in the meridional wind during the southward migration at the point where the tern is. And the plot on the right shows the changes in the zonal winds expected to be seen over the course of the next century. So there are significant changes in the winds that the terns will experience during the migration, but the patterns are quite complex and it's not 100% clear what the impact would be on the terns themselves. So we also use particle tracking to build virtual terns with like virtual tern behavior, which do a good job of reproducing real tern migration pathways. And we looked at how the migration time of these terns might change in the past and also in the future. But we found absolutely no significant change in the migration time required to go from the south to the north. So these wind changes, although they're there, may not have a significant impact on the terns themselves, possibly. We also looked at sea ice, and this figure on the left shows the observed changes in sea ice extent around Antarctica and the known locations of where the Arctic terns are. And there's a very good agreement between the two. So the Arctic terns follow the sea ice margin very, very closely. So understanding how this might change in the future will be very important for understanding how the location of tern populations might change in the future. But unfortunately, UKESM and many of the other CMIP6 models are not particularly great at reproducing observed sea ice extent. So making predictions for this in the future is a little bit challenging at the moment. And then finally, we also looked at productivity because the Arctic terns forage on krill during the migration and in the Southern Ocean. So understanding how krill populations might change in the future is also really important. So we firstly validated chlorophyll concentration as a proxy of krill populations. We then looked at how krill populations might change in the past and in the future over the lifespan of an Arctic tern. So this figure on the left basically shows the trend that an Arctic tern would experience over its lifetime in krill population size in its foraging sites as a function of its birth date. So in the past, Arctic terns saw very little change in the expected krill population size in its foraging regions. But starting from the 20th century, according to UKESM, Arctic terns in 3 of their foraging sites start to see a negative trend in the krill population density in their foraging sites. So that may suggest that in the future, Arctic terns may see a reduction in the krill concentration in the regions where they forage. Yeah, thank you.